Okay, so picking up where we left off from class, section 2.3, and like I said, I will embed questions from your take-home quiz that it will be due on Monday in class. Make sure you write the question out completely and answer it completely. And it's going to be due at the beginning of class. If you know that you are not going to be in class, you need to make sure you give it to someone else or email it to me, but it needs to be there. I don't accept late quizzes. Okay, so from synthetic division, we can easily conclude a very nice theorem, which is called the remainder theorem. So hopefully all went well in class and we got up to synthetic division. And so what the remainder theorem does, if we have some polynomial function f of x and it's divided by x minus k, so some linear factor, the remainder r is actually equal to f of k. Okay, so how can that be useful? Well, if you don't have a calculator, and instead of evaluating the value straightforward, you can use synthetic division, find the remainder, and there you have your answer. So let's look at this example. So use the remainder theorem to evaluate the following function at x equals negative 2, and f of x equals 3x cubed plus 8x squared plus 5x minus 7, right? And do that. Okay. So first let's recognize, what's our k in this example? Our k is negative 2, all right? Remember, we might be used to the form x minus k, so you see that x minus k? Well, if you have it as x equals negative 2, then that means it's really x plus 2, and so k is going to be negative 2, okay? And so we use synthetic division, all right, to divide f of x by x minus k, and our remainder will give us f of k. So let's look at this. Okay, and so we set up our synthetic division. All right, so it's sort of the flip of long division, right? The bar is sort of flipped. We look at the coefficients of our polynomial. Okay, and I'm sorry, I forgot to put, that should be 3x cubed, right? So 3, 8, 5, negative 7, right? We bring down the 3, negative 2 times 3 is what? Negative 6. And then that's going to give us 2. Negative 2 times 2 is negative 4. That's going to give us 1. And then that's negative 2. So that's negative 9. So there we have our remainder. Okay, so that tells us that f of negative 2 is negative 9. All right. And if we wanted to, we can check straightforward. And by plugging in, wherever we see an x, we would plug in a negative 2. And that's 3 times negative 8 plus 8 times 4 minus 10 minus 7, negative 24 plus 32 minus 17. And you can confirm that you're going to get a negative 9. Excuse me. So it's really nice. Like I said, it's really nice to use synthetic division, because synthetic division, we didn't deal with large numbers, right? And not to say that's very large, but when you have a big long polynomial, it's nice to do this. So this is a remainder theorem, which is a very useful theorem. Okay, which brings us to, now that you've learned the remainder theorem, I'm going to give you quiz question 2. And yes, I'm going it out of order, which means you're going to have to watch the entire video to see where is question 1 going to be, because you never know. But this is question 2. You need to put your quiz solutions, your answers in order. So I should see question 1, question 2, then question 3, although I'm giving it to you in different orders. You should write this down just on a separate sheet of paper and not on your final sheet of paper that you're going to turn in. Okay, I will mark off if they are not in order. So let me just say that in the video. But question 2 says find the remainder of x cubed minus 4x squared minus 5 divided by x plus 2. And you're going to use 3 ways. You're going to use long division, synthetic division, and the remainder theorem. Okay. The good thing is you should all end up with the same answer for each of those, right? However, you need to make sure your steps, the processes that you use are different, right? Long division is different from synthetic, which is different from the remainder theorem. Or is it? I'll leave that up to you to answer that. But nevertheless, that is quiz question number 2. Okay, so now we're on page 6, I believe, of your notes. And let's see. Oh, so question. Yeah, I had it different in my notes. Okay. What does it mean that 5 is a factor of 45? So when I say 5 is a factor of 45, what does that mean? Well, that means that 5 times something equals 45, right? And in general, to find that something, okay, we divide both sides by 5. Okay, simple enough, right? So i.e., in other words, our something is equal to 45 divided by 5, which we know is 9. So 9 times 5 equals 45. And I know you're probably saying, okay, that was straightforward, Dr. Brown. We know that, right? That's just basic math. But the thing about it is, if you understand that, then the same idea will work for polynomial equations or functions. ALs. Okay. I don't know why this is on this page. I thought I put it on the next page. But it just says if you know a factor, then you know a root. Okay. All right. So, and B, if you know a root, then what? You know a factor. And remember, when we say root, we're also talking about a solution or 0 of our function. Okay. All right. So if, let's say, x minus 1 is a factor of this third degree polynomial here, then that means x minus 1. If it's a factor, then that means x minus 1 times something will equal what? X cubed plus 2x squared minus x minus 2. Okay. And that something is going to equal x cubed plus 2x squared minus x minus 2 divided by x minus 1. Okay. So again, it's the same process we did with that row number. All right. So now we can use long division, or what? We have our nice synthetic division to figure out our factors, right? So let's go ahead and set this up. So we have 1, 2, -1, -2, right? Synthetic division, bring down that. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3 is 3. 2 times 1 is 2. Now, here's the thing. You automatically know that if I'm telling you, oh, no one told me that I forgot the OR factor. You guys need to speak up. Okay. Don't mind me. If I'm telling you that it's a factor of a polynomial, then that automatically means your remainder will be 0. Okay, so keep that in mind. Please make sure you get that. If I'm telling you that something is a factor, and that's what I told you all, when you're reading questions on exam quiz on anything, make sure you read it carefully, because there's a big difference between saying verify versus determine, right? If you're verifying, that means I'm telling you this is how it is. You need to verify that it's the case, whereas determine, you don't know. So if I'm telling you that x minus 1 is a factor of that polynomial, then that means whenever I do, if it's synthetic division, if it's long division, my remainder will be 0. Okay. And so we see that that's the case here. Okay. And so now we have, well, what do we have left here? Well, starting from the back, 2 is a constant. And so that's 3x, and that's x squared. So that tells us that x minus 1 times x squared plus 3x plus 2 equals what? Our original polynomial, right? Our dividend, x cubed plus 2x squared minus x minus 2. Now, what if I wanted you to find all the solutions to this? And that's where we're moving to, okay? So what are the roots or solutions to this? Well, we just take what we factored, what we broke down, right? Set it equal to 0. So x minus 1, oh, that x, okay, equals 0. Or x squared plus 3x plus 2 equals 0. So x equals 1. And then what will we get? The arrow doesn't look like it's pointing to that. What will we get for this? Well, you guys see that that factors nicely, right? X plus 2, x plus 1. And so x equals negative 2 and negative 1. Okay, so then the solution, or the roots, although I didn't ask for it, but it's nice we can find, and that's where we're going to go. That's where we're going in the future chapters, is negative 1. X equals negative 1, negative 2, and negative 1. Positive 1, negative 2, and negative 1. Okay. I think it's time for our next quiz question. All right. So here's your quiz question number 1. For the polynomial function f of x equals x cubed plus x squared minus 12x, I want you to find A, the x and y intercepts, B, state the maximum number of turning points, and then C, using zero, sign charts, intercepts, and whatever other information that we've discussed, I want you to sketch the graph of the function. All right, so that's your first question. Yes, there are only 3 questions, so there's one more question that I'm going to put here. What I want you to do is write them on a separate sheet of paper. So question 1, question 2, question 3, I want you to put them on a separate sheet of paper. That will help me grade. It'll be easier for me to grade. I'm happier and I'll be nicer with grading perhaps if everyone follows those directions. Okay, let's move on. Okay, so I don't like going over 15 minutes in a video, but I think I don't have too much to cover, so it might be a little longer than 15 minutes, but if I stop talking now and continue, then it won't. All right, so here is our next theorem. So we talked about the factor theorem, remainder theorem. Now here's the factor theorem. And the factor theorem says x minus r is a factor of the polynomial p of x if and only if r is a root of the equation p of x equals 0. Okay, and all that's saying is that, i.e., when you put in r into your function, you're going to get 0. Okay, so let's show example 6. Show that x minus r and x plus 3 are factors of this polynomial. Okay, so using this theorem, and again going back to this little side note here, if you know a factor, then you know a root. If you know a root, then you know a factor. What we can conclude is that, why did I put x minus r? X minus 2 on a number there. Okay. Well, how can we figure that out? Well, now we can keep in mind what our remainder theorem is telling us, right? Our remainder theorem. So in proving this tells us that since x minus 2 is a factor, then x equals 2 and x equals negative 3 are roots. All right, and that's all I did was set those both equal to 0, and you'll get, in terms of our synthetic division, that represents our k values. So if we use synthetic division and show that the remainder is 0, then remember that tells us that r, well, we want to, r is, this is, we're looking at r as 2 and negative 3, but that will tell us that we're going to get 0. Okay. Now you can, if you want to, plug it in and you can just plug in f of 2 and f of negative 3 and show that you're going to get 0. But again, thinking about it, if you don't have a calculator, those numbers to the 4th and to the 3rd, those numbers can get big. So it's easier and nicer to deal with just doing synthetic division. Okay, so let's set it up for the factor x minus 2, which corresponds to 2 being our root, right? And that's our k, okay, in terms of our synthetic division. All right, so that's going to be 2, that'll be 4, that'll be 11, that'll be 22. That'll be 18. That'll be 36. That'll be 9. And that'll be 18, which gives us 0. And that you just showed that 2 is a root, or you showed that 2 is a root of the polynomial. Let's call it p of x, or I think it's called f of x, which means that x minus 2 is a factor, which is what we needed to prove. Okay, so in your notes, I want you to do the one for x plus 3, which corresponds to x equals negative 3. Okay, and again, you should get back out 0. Okay, when you do your remainder. Okay. Let's look at this last problem, and then I will give you all your quiz, your last quiz question. Given that 4 is a root, solve this equation. So how can we solve this third degree polynomial with only one root, with only one 0? Okay, well, here's how. It's very nice. Actually, I might need one more room than that. Let's start up here. Since 4 is a root, which means it's also a 0, right? Or 0 of this function. That means that x minus 4 is a factor of x cubed minus 12x minus 16. So what we can do is synthetic division, right? And be careful here, because when we're missing an x squared term, right? So we need to use 0. Long division, you don't have to, although I would still recommend to use 0 as your placeholder. But in synthetic division, you have to, or your answer will be incorrect. So please be careful on that. 1, 0, negative 12, and negative 16. Okay. Well, and I'll say this too. If you don't get 0, you know that you've done something wrong, because I'm already telling you that this is a root. So that means you should get 0 as your remainder. All right, so that's 1, 4, 4, 16, 4, 16, and voila, we have 0. And what are we left with? Well, that's 4 plus 4x plus x squared. Okay, and so this means, well, we don't even need to do that. We already know 4 is a root, right? This is the other factor. So let's factor that, and we find our other solutions, or our other roots to this polynomial. So we just set it equal to 0. This also factors nicely. If they don't factor nicely, you have quadratic formula to use. So just keep that in mind. And this is negative 2 with, we have a multiplicity, right? So we have multiplicity 2, okay? Or it's also called a double root, okay? So our answer then would be x equals 4 and negative 2 with multiplicity 2. Okay. All right. And that is the end of the notes. That is the end of the notes. Let me give you the third. Oh, this is fun. This is a fun question. I want you to write a short memo to your grandparent, or maybe a student, a younger student, elementary school student if you want, explaining the intermediate value theorem. I'm not looking for you to copy the definition in the book. I'm actually looking for you to see if you can explain it and break it down to either an older person who's not familiar. Now, if you have a grandparent that's a mathematician, that might be different. But if not, someone who is totally unfamiliar with this theorem, I want you in your own words to explain it. You can use a function, you can use a graph to explain this theorem, but I really want you to be thoughtful and creative in explaining it, because this helps you to make sure that you understand what the intermediate value theorem is saying. Okay, we are done with the notes. I will see you all in class.